Professor Mechael Berk is an NHMRC Senior Principal Research Fellow and Alfred Deakin Chair of Psychiatry at Deakin University, where he heads the Impact Strategic Research Center. He's also an Honorary Professorial Research Fellow in the Department of Psychiatry, the Florey Institute for Neuroscience and Mental Health, and Origin Youth Health at Melbourne University, as well as in the School of Public Health and Preventative Medicine at Monash University. He has published over 500 papers, predominantly in mood disorders. Michael's major interests are in the discovery and implementation of novel therapies and risk factors and prevention of psychiatric disorders. He is the recipient of a number of grants and awards and a lead investigator in a collaborative research center. Today, Professor Berk will be speaking about oxidative and inflammatory biomarkers as targets for novel therapies. Welcome.
Thanks, Anil. So I've been motivated for the last too many decades to try and help understand how the treatments we've got work and also to try and develop some novel therapies. And the reason why is we've got a real crisis in drug discovery in our discipline. So this is a quote from Steve Hyman, the director of the National Institute of Health, and you can see he's bemoaning the fact that drug discovery is at a near standstill for major psychiatric disorders, schizophrenia, depression, autism, bipolar disorder. It's been an awful long time since we've had anything like an avalanche of new drugs. So the field is really very stagnant, and this is a real problem for all of us and our patients. So somebody coined a thing called Eroom's law, which those of you who can spell backwards would know this is Moore's law backwards. So every 2 years, your computer doubles in speed and halves in price. But Eroom's law says that every 2 years, the number of drugs that get discovered halves, and the cost of developing these drugs doubles. And this law, sadly, has held up very well. Now, this is not good news for us or for our patients. So we've been pondering for some time, how the hell do we discover new drugs? Where are these new drugs going to come from? Now, industry takes a purist approach. So they say, number one, give me a clear pathological foundation, give me a target, a molecular target, I'll find a drug that binds to the target and fixes it. Well, the problem in psychiatry is twofold. We don't have pathophysiology. Nobody knows what the abnormality is. We don't have a Huntington's gene and a Huntington's protein to target. We have no clue what the core biology of most of these disorders are. And the second is, and as a consequence, there's almost no examples of drugs developed that way. Very sad. But that's where most of industry's energy goes. The second path is a byway. So it doesn't aim for a single target, but in a loose and messy and much less purist way, aims for networks or systems. And the ones that I'm interested in, I'll be talking about, are oxidative stress and inflammation. Because I think we've got some promise in that area, and I'll show you some data of where that might be. But there's not a lot that's come out of that yet. Sadly, all of our drugs come out of the third pathway, which is, oops, how the hell did that happen? So on the basis of completely accidental findings, somebody decides to give a metal salt to a dog and it calms them down. Well, let's try it in humans. Somebody decides to give an antihistamine to people who were sniffy, and it either cheered them up or they made them less crazy. And that's basically the history of psychopharmacology. Oh yes, anti-tuberculous drugs made some people chipper. And everything else has been just re-engineered drugs that work the same way. So we don't have a wonderful pathway for new drug discovery. So we are interested in the idea of biomarkers that are able to give us some clue as to what's going on in these psychiatric disorders. And as I said, we're mostly interested in these biomarkers of inflammation and oxidative stress. But biomarkers are not just biomarkers. They can tell us something about components of the illness. So they can tell us, are you at risk of a disorder? And I'll show you an example of that later. They can, ideally, the Holy Grail is a biomarker that tells you that a biomarker of diagnosis. In other words, if you have this biomarker, you have this disorder. Well, that's been completely elusive to date. We haven't found any biomarker that's clearly tied to a disorder, because that would give us the pathophysiology. We've got some biomarkers of state and acuity, things like BDNF. We've got some biomarkers of stage of illness. We're very keen to look at biomarkers of treatment response. Ajit, I think, spoke about that with the genomics, and there's promise there, but as yet, I think, as Ajit correctly said, I don't think it's gone ping yet. And lastly, we got some biomarkers of prognosis, but again, we're waiting for ping. So I'm going to start off by talking about inflammation and oxidative stress. And I'm not going to be talking a lot about where the hell this oxidative stress and inflammation comes from, but what I want to say is really summarized in this one slide, and that is every single known risk factor that we have for major psychiatric disorders seems to be transduced through inflammation and oxidative stress. So the way that we're looking at people who have poor diet, whether they use substances, you haven't got enough vitamin D, you're obese, you've got a leaky gut, you're subject to stress, all of these things seem to be transduced through cytokine and oxidative signaling. Now, to go into this in detail would be an entire talk in its own, which I'm not going to be focusing on today. But you'll just have to, I'm just going to give you one example of how this works in the next slide. And this is a really fascinating slide. I really loved this study when I saw it. So it's talking about childhood bullying as a predictor of adult inflammation. So if you are bullied as a child, it upregulates your inflammatory set point. So if you look over here, this is the extent of your bullying versus how high your C-reactive proteins are. And you can see this beautiful linear relationship between C-reactive protein and how badly bullied you were. But on the right-hand side of the figure, you see something even more interesting. So in the blue, again, this is looking at C-reactive protein, a marker of inflammation. If you were not bullied or a bullier, that's blue. If you were a victim of bullying, in the green, you had much higher C-reactive protein. If you were a victim and you were a bully, your levels of C-reactive protein are the same as controls. But here's the interesting one, the kicker. If you're a bully, your levels of C-reactive protein were actually lower. So there's something about the way that this whole social defeat, social victory thing is transduced through cytokine signaling that I think is absolutely fascinating. And as I said, this is a whole new world.